on the docket here is all right, guys, so let's take a second and we'll talk about formal charges. It's one of the last things that we need to take a look at before we look at resonance structures. So it turns out that formal charges are important. It must be calculated for each atom of a given Lewis structure. Now, there's going to be patterns to this. So unlike perhaps general chemistry, we're going to be able to look at this pretty quickly and figure out what the formal charge is without actually having to do any calculations. Now, that being said, let's take a second and let's go through a method that can help you kind of learn that pattern. And if you get stuck, you can always calculate it on your own. So the first step is to draw your Lewis structure, okay, including lone pairs and unpaired electrons. So, for example, here's a structure CH3NH3. The question is, what's the formal charge? Does carbon have a formal charge? Does nitrogen have a formal charge? Probably hydrogen doesn't because it's at the end. So what we're going to do is we're first going to determine the number of valence electrons that the atom wants to own. Now, this will be equal to the group number of that atom in the periodic table. So we simply look at the periodic table and we go look above our column there, and that number is going to be equal to what the number of electrons the atom wants to have. So for CH3NH3, that means that we want 5 for nitrogen and 4 for carbon. Now, sometimes students get confused and think, well, 5, but doesn't nitrogen want an octet? Yeah, these are two different things. So we're just calculating formal charge here. It's still going to have a full valence. Okay, now that's not always going to be the case. As we go through, we can have incomplete octets, for example. They give rise to positive charges on carbons. All right, so we do once. Step 3. Determine the number of valence electrons that the atom actually owns in the Lewis structure. So we're looking at it, and I like to think of it this way. For every single bond that we have, every line that's drawn, so if we draw a line between a carbon and an H, carbon is bringing 1 electron to the table for each one of these lines. So if there's a double bond over here to some other atom, for example, then carbon would bring 1, 2 to the table, right? Have another atom over here with an H, and it would bring another atom there. So that would bring 4. Okay. If we have lone pairs, we count them both, and if we have single electrons, we count 1 for that. All right, so for CH3NH3, carbon is bound to 4 atoms, and nitrogen is bound to 4 also. So you got 4 for nitrogen here, you got 4 for carbon. And that's because the Lewis structure of this is this. Right, so when we look at carbon here, carbon's bringing 1 of these electrons, 1, 1, and 1. This is where if you look in some textbooks, you'll see the formula is 1/2 the number of bonding electrons. So you could do that if you want to also. Now, the formula for the formal charge is easy to remember. It's wants minus owns. So it's the number that we want minus the number that we own. So when we look for carbon, how many does it want? Right? The number that it wants is up here. It wants 4 for carbon. For nitrogen, how many does it want? It wants 5. So 5. Minus what it owns. It owns 4 for nitrogen, and we own 4 for carbon. So minus 4, minus 4. So for carbon, it is 0. For nitrogen, it is positive 1. So it's pretty much that straightforward. So once we're done with that, we got to put in the actual number. So we would write CH3, NH3, and we don't usually write a +1. We just write a plus. And that plus means that it's positive 1. If it was 2, then we'd write a +2. Right? If it's -1, we just write a negative. Now, the overall charge of the structure is equal to the sum of all the formal charges of the individual atoms. So we can see situations where you have a plus and a minus in a molecule, but when we write out the molecular formula, we don't write it out with a positive or a negative because they add up to 0 here. Now, When you look at the pattern, this, and I wouldn't spend time trying to memorize this, but this is pretty much it. So we're going to see carbon, of course, lots, nitrogen, oxygen. Those are the three most common. And then boron to a little degree, and the halogens show up, but those should be pretty straightforward. So if we go down below, remember carbon wants 4. So how many does it own? Here it owns 4, so it's a formal charge of 0. Here we own 1, 2, 3. So 4 minus 3 gives you plus 1. And here we own 1, 2, 3, 4, 5. 4 minus 5 gives us minus 1. All right, now I won't go through them all, but you can see the pattern here with all these structures. All right, guys, so the next section that we're going to talk about is resonance structures. And we need our own lecture for this because this one's going to be a little bit longer as compared to our discussion here of formal charges.